Welcome to the AI for Career Success video overview by Curt Robbins, where we help you get smarter than your competition.
Today, we're analyzing a compelling article from ZDNet, published on January 2, 2026. It's written by Webb Wright and is titled How DeepSeek's New Way to Train Advanced AI Models Could Disrupt Everything Again. The piece details a potentially transformative development from the Chinese AI firm DeepSeek, which could alter the fundamental approach to building advanced AI models.
Here's our agenda for this analysis. We'll begin by contextualizing the current AI development landscape. From there, we'll examine a fundamental challenge that arises when scaling these models. Then, we'll explore DeepSeek's elegant engineering solution to this problem. And finally, we will discuss why this breakthrough has such significant implications for the industry.
So, to fully appreciate the significance of DeepSeek's research, it's essential to first understand the competitive environment in which it was developed.
For some time now, the prevailing wisdom has been that building frontier AI models is a game of resources. The field has been dominated by a select few corporations with the immense capital required to fund the massive computational overhead. The barrier to entry has been, in a word, astronomical.
However, this isn't the first time DeepSeek has challenged this paradigm. If you recall, back in January of 2025, they released their R1 model. What was remarkable was that it offered capabilities that rivaled top-tier models from competitors like OpenAI, yet it was reportedly trained for a fraction of the cost. This sent a clear signal: superior engineering could serve as a powerful equalizer against raw capital.
And that history of engineering prowess brings us directly to the core technical problem that DeepSeek's latest research aims to solve.
At a foundational level, large language models are constructed using neural networks. You can conceptualize these as a series of interconnected computational layers. A piece of information, or a signal, must pass through these successive layers to be processed.
Now, here's the inherent challenge. A common method for increasing a model's power is to simply add more layers, making the network deeper. The problem is that with each additional layer, the original signal is at risk of degrading. The analogy used in the source article is quite apt. It's like a message becoming distorted in a game of telephone.
The DeepSeek researchers themselves frame this as a delicate balancing act. They aim to, and I quote, better optimize the trade-off between plasticity and stability. In this context, plasticity refers to the model's ability to learn and adapt. Stability, on the other hand, is its ability to maintain the integrity of that informational signal as it travels through the network. Achieving both is the crucial and very difficult goal.
So, how exactly did DeepSeek address this trade-off? Let's now turn to their engineering solution.
Their work is an evolution of a recent framework from 2024 known as Hyper-Connections, or HCs. The objective of HCs was to create more diverse pathways for information between the neural network layers. However, this approach proved to be extremely memory-intensive and, somewhat counterintuitively, often increased the risk of signal degradation.
DeepSeek's innovation is what they call Manifold-Constrained Hyper-Connections, or MHCs. Rather than simply adding more connections, this new architecture intelligently constrains the hyperconnectivity. It's a more targeted and efficient design that preserves the intended informational complexity.
This comparison really illustrates the elegance of their solution. Where the original HLC framework was hampered by high memory costs and a high risk of signal loss, the new MHC architecture successfully lowers that memory footprint while protecting the signal's integrity. It effectively mitigates the drawbacks of their earlier approach.
So, we've established that this is a sophisticated technical solution. But let's zoom out and consider the broader strategic implications. Why does this really matter?
It comes back to this critical point from the ZDNet article. This work reinforces the idea that major breakthroughs in AI are not exclusively the domain of those with the most capital and computing resources. Innovation can be driven purely by clever engineering.
The potential impact here is significant. This research could help democratize the development of frontier AI by empowering smaller, more agile developers. It shifts the competitive focus away from pure capital and toward engineering ingenuity. And as a final point, there's widespread speculation that this very framework will form the architectural basis for DeepSeek's highly anticipated R2 model.
Ultimately, this development leaves the entire AI industry with a critical question to consider as we move forward. Will the next phase of AI innovation be defined more by engineering elegance than by sheer financial investment?
Thank you for watching. This is where we teach you AI and help you get smarter than your competition. We encourage you to subscribe to the AI for Career Success YouTube channel. And please, do like, comment, and share this overview. as it helps us reach a wider audience of professionals like you.